Hello and welcome to the Love of Brains podcast. I'm Dana, and I have to admit I'm a bit of a brain nerd. I bought my first book about the brain and neurology when I was 12 years old. I had a son diagnosed with a severe learning disorder, so I took my hobby to a new level. I'm here today to share what I've learned over the years. My hope is that you walk away with some new knowledge and a sparked interest in the brain. Thanks so much for being here and taking the time to listen. Hello, everybody, and welcome to the Love of Brains podcast. Today, I'm going to talk a little bit about neuroplasticity. I am so excited about this topic. It's really one of the main reasons why I started this podcast. Plasticity is your brain's ability to change, and in my opinion, it is your superpower. So let's look at a technical definition of plasticity. Neuroplasticity is the ability of the brain to form and reorganize synaptic connections, usually in response to learning or life experiences or during recovery after traumatic brain injury or stroke. So what does this mean? Well, we can get technical. We can look at neurotransmitters and excitatory and inhibitory actions. But what I really want to talk about is why you should be excited about plasticity. Because it is your ability to change. It's your ability to change your brain for the better. You can do this by stimulating your brain with music or movement, or visually stimulating your brain with art. So neuroplasticity is our brain's ability to rewire and make new connections. It's your ability to learn new things, to improve the things you're already doing. So you might say, where are these changes happening? Well, it depends. So to explain it better, I need to tell you that the brain actually has different sections or lobes that are responsible for different things. So an example of this is, let's take your occipital lobe. It is located in the back of your head, and it is mainly responsible for interpreting and processing vision. So it's responsible for perception of objects, their color, their form, their motion, if moving. And then we'll look at the frontal lobe, because that seems to be a pretty popular area of the brain. We usually think about frontal lobes being associated with executive function and emotional control. It's responsible for the ability to control urges like when you're angry. It helps you control the urge to jump a counter and grab someone by the throat, or to do something that you might regret later when you're calmer. So what is my point of talking about different areas? Well, when these areas are stimulated through music or movement, like I was mentioning before, the neurons responsible for processing that input become active or fire. Neural activity is considered firing, and I'm sure, I would hope, or I think some of you have heard the phrase, what fires together wires together. And the idea of that is, if stimulation is going to multiple parts of the brain or multiple areas of the brain, and that's causing the neurons to fire, when multiple areas of the brain are firing at the same time, that means they're firing together, and eventually they will wire together, which means they will start to communicate, and you will develop new neural connections, which is what is meant by what wires together, fires together, or fires together, wires together. I keep getting that wrong. So the idea is to stimulate those same areas over and over again and eventually develop a new connection or wire them together. So why is this important? Well, because multiple areas of the brain have to work together to complete an action or a thought. And an example of that is the ability to speak. The ability to speak, to have a conversation, involves multiple areas of the brain. And really, you have to have the ability to recall words, to take those words and formulate them into a coherent sentence. And then the motor planning ability to move the right muscles and to make an appropriate sound, the right volume, to pronounce it clearly so that it can be understood. It just requires a lot of involvement, multiple areas of the brain involved in speech. And I don't know if you guys have ever seen MRIs, the MRIs pictures of the brain that show, they're real colorful. They're showing different areas of the brain as they fire. They light up. So for an MRI scan, you'll see like pinks and blues and greens or yellows and oranges, depending on what they're trying to indicate. But it'll show you areas and sections that are firing and communicating. And so this is how speech and language develop really for children, is that these areas start firing and wiring together. And that's really a good example of showing the brain changing and growing and making new connections. So staying along that line of the brain changing and growing with new connections, another interesting fact about different areas of the brain being assigned different tasks is that those actual areas of the brain can be strengthened and grow in size when you target that area with specific input. So that area will get larger. And I want to clarify, we're not talking about the size of the brain increasing. We're talking about a particular area taking up more real estate. So an example of this would be like, I own 10 acres of land. I'm growing crops on 1 acre, but I decide to use 4 acres to grow crops. I still only have 10 acres, but I'm now dedicating more area to growing the crops. So now I still have 10 acres, but I'm growing crops on 4 acres instead of just 1. So I've increased the area dedicated to the crops. And that's kind of what happens in the brain, is that particular area is being used a lot or targeted or used a lot. So it starts to grow. And one of my favorite examples of this is a study that was done on London taxi cab drivers. So the streets of London were developed slowly over the centuries. There was no urban design grid to plan development like you would see in New York City or DC or Dallas. The streets just kind of grew over the centuries, all craziness. So finding your way around London before GPS would probably require a map in your hand. And of course, for the case of a taxi driver, it required having a spatial map of London in their head. So taxi drivers were required to train anywhere from 2 to 4 years to memorize the location of every street in the city. And so, they were walking around with these spatial maps of London in their heads. So then they were given these tests. The drivers were required to have the ability to not only know the most efficient and direct route from one location to another, but they also had to come up with any landmarks that you would see along the way. So that's a lot of memorization and connecting. So recall all that. So it took a lot to get to qualify as a taxi driver. So a group from the University College of London were curious about what the effect of this type of memorization and studying would have on the brain. So they took a look at the taxi drivers, the taxi cab drivers, and they looked particularly at an area called the hippocampus, which is the part of the brain responsible for spatial intelligence, which is what you would have to have in order to have a sensical map in your head of this and be able to use it, visualize it maybe, and recall it. So anyways, your hippocampus is what is used for that. And what they found is that London cab drivers had a significantly larger hippocampus than the average person. In fact, they found that they had larger hippocampus than anyone they had looked at, which is amazing. They also found that as the drivers retired and stopped relying on this spatial memory and stopped using it on a daily basis, their hippocampus started to shrink back to what we would consider a normal size. So this is really, that's a cool example of how constant input and use of an area can affect the brain and resize it or reorganize it. So I want to take a quick look at a few therapies and the idea that neuroplasticity is the basis behind the therapies. So let's look at physical therapy, for example. So say someone has a stroke and loses the ability to move a limb or to use a limb. So a quick fact here is the left side of our brain controls movement on the right side of our body, and the right side of our brain controls movement on the left side of our body. So if you look at the frontal lobe, I mentioned earlier, I was talking about the frontal lobe being responsible for executive function and emotion control. There's also a small part of the frontal lobe called the premotor cortex, and it initiates movement. So it's involved in movement. It's the initiation of movement. So if you have a traumatic brain injury or stroke that causes damage to the left side of your premotor cortex, you would most likely have problems with movement on your right side, somewhere on the right side of your body. So physical therapy would be aimed at trying to regain those connections and regain movement of the right side. So if you targeted the left premotor cortex with therapy, you would hope, depending on the damage, that those connections could be remade. And that's really the basis of physical therapy. Another look at therapy is considering that there is therapy for there's habilitative therapy and rehabilitative therapy. And the difference in that is a rehabilitative therapy is when someone had a skill and lost it, which is what I was just talking about. So it's helping to regain or attempting to regain and restore the skill. Habilitative therapy is seen in individuals who never had the skill and they're trying to develop it. And an example of this would be in the case of speech therapy for a child who's slow to develop speech or is struggling to meet those milestones and make those connections. So the idea there is that you would target and work on targeting different parts of the brain, but work on different parts of speech development and hopefully make connections that for whatever reason weren't made. All right, so that's all I have to say about plasticity for today. I could go on for hours because it's just such a fascinating area. Maybe we'll talk again about it later. Right now, I just hope that you enjoyed this little introduction to neuroplasticity and that you are interested in learning more. I think there's so many good stories out there about recovery after stroke or brain injury. And if you found any of this interesting and you want to look into more examples of plasticity, I really highly recommend Dr. Norman Doidge's books. He's got two. One of them is called The Brain's Way of Healing, and the other one is The Brain That Changes Itself. They're both really full of fascinating stories about or examples of neuroplasticity and recovery, which, again, I like to refer to neuroplasticity as our superpower. So I'd like to invite you back in 2 weeks when my topic will be interoception. It's another exciting topic that I think you'll find really interesting. It's all about your awareness of the internal state of your body. It's the awareness of inner sensations like your heart rate, when it increases, hunger, whether or not you have a full bladder. It's just internal monitoring, and it's governed by another part of your brain called the insula. I don't think you want to miss this one. I'm telling you, you don't want to miss this topic. So goodbye for now. Thanks for coming. Hopefully we'll see you soon, and take care. Thanks, guys. Thanks for listening to the Love of Brains podcast. I hope that you enjoyed it and are excited about coming back for new episodes. Don't forget to visit our website at theloveofbrains.com and follow us on Instagram at theloveofbrains. Thanks for spending time with me, and I look forward to seeing you again.